Welcome to Seeing More of the Universe. I'm your host, Alyssa Goodman. If you've watched this whole series, you've heard me talk a lot about a software program called Glue. I love Glue because it's the fulfillment of a dream that I've had for pretty much my whole career to have an easy to use software package that can combine so many of the other principles that you can learn about in this whole series of videos that include things like making use of the high dimensionality of many data sets, making use of many data sets at once, and making use of concepts that come from studies of cognition that tell us that if we can link together different views live, we can really understand what we're seeing in visualizations of data much more clearly than we can otherwise. So first, a word from our sponsors. I should explain that GLUE at the moment is funded largely by NASA and the NSF. NASA chose it to underlie the data visualization needs of the James Webb Space Telescope. And the NSF has given us money to expand the user community and to develop a Jupyter-based version of GLUE that I'll talk about at the very end of this video. But first, what is GLUE? Let me play you this very short video that gives you a very quick demonstration of Glue's abilities, and then we'll talk in a bit more detail.
Glue is a program for data exploration and visualization that allows users to better understand the relationships that exist within and between datasets. The main interface of Glue provides different data viewers. In this example, the viewer on the left shows an astronomical image of a region where stars are currently forming, and the two viewers on the right show a scatter plot and histogram derived from a separate catalog of stars in this region. The viewers support interactive selection of data subsets, and selections are automatically propagated to other data viewers. In this example, the selected stars are shown in red in all viewers. One of the main features of Glue is the ability to link together different datasets using linear or nonlinear mapping functions. In this example, we have linked the image and catalog data to make it possible for the stars to be shown on top of the image. Three-dimensional data viewers are also available. In this example, we can see the 3D distribution of all earthquakes recorded around the world in the last 6 years. The points are colored by the depth of the location where the earthquake originated. The lighter colors show earthquakes that occur deeper in the crust. This viewer also supports highlighting of selections made in other viewers, as well as direct 3D selections. Glue is designed from the ground up to be a multidisciplinary tool and allows users, for example scientists, to develop plugins to support particular data formats or data viewers. This example shows a volume rendering visualization of medical data that consists of braid scans. We have used Glue to overplot two different datasets, and we can interactively explore this data in 3 dimensions. Finally, Glue is written in Python and makes it easy to interact with the data and subsets using a built-in IPython terminal. For example, we can define new subsets programmatically and have these be automatically highlighted in the interface.
In that video, you heard the word selection a lot. So let me explain very quickly the theoretical concept here. If you see this cartoon, you'll notice that there are highlighted regions in red in 4 different kinds of displays here. A standard 2D image, some kind of data abstraction, a statistical plot, and a representation of the data in 3 dimensions. The idea of selection is that you can, in real time, select a salient feature in any of these plots and have the corresponding region highlight in any of the other plots. This idea, importantly, was first brought to us by John Tukey, and there's a whole literature about it. But for now, we'll just say that Glue takes advantage of it very heavily. So Glue has a website. Here it is. And you might wonder, what is that beautiful image in the middle of the website? Well, it turns out it's probably what earned me an FBI file. We have a little antenna shown in the upper left on the roof of the Harvard-Smithsonian Center for Astrophysics that monitors the 3-dimensional positions of airplanes over Boston. And we collect this data set to be able to explain what Glue is to non-astronomers and non-medical imaging experts. So if you take a look here, you'll see a bunch of plots that are actually used in some exercises that we assign to students to learn how to use Glue. So I don't want to give away what's going on, But let me just tell you that there's something very interesting about planes that are landing and planes that are taking off. But just to emphasize again the importance of so-called wide data in addition to big data, if you live in Boston, that plot in the lower left that actually has a multicolor map of the Boston area in the background is really key to understanding what's going on with the paths of airplanes. Importantly, though, a user here could highlight any of these data, select them in one plot, and have them show up in another. We talk a lot more about glue in other videos in this series, so let me talk here more about the architecture of glue and how it's meant to work. This is a diagram that gives you a good glimpse into the three meanings of the word glue. It is not an acronym. It has to do with gluing things together. And the three things that it glues together are data sets. We'll talk about that one in a minute. Gluing together plots, so that you can make these kind of interactive selections I discussed a minute ago, and gluing together different tools, like, for example, Worldwide Telescope that we highlighted in some of the other videos. Here you see just a little cutout that gives you an idea that all the data sets on the left-hand side of this otherwise complicated looking screenshot have been linked in some way so that their shared attributes are understood by the program. In this particular case, those shared attributes happen to be astronomical coordinates, but keep in mind that they could be anything, not even spatial. For example, if you want to glue together a simulation and an observation to compare statistical properties, you could glue on intensity of something modeled in the simulation and something actually observed. The next meaning of glue has to do with gluing together plots based on the concepts first put forth by Tukey that we discussed a minute ago. So now you probably understand better the origin of Glue's logo, showing all the different kinds of plots with a red highlighted selection made amongst them. In the image I'm showing you here, which is a screenshot, a selection has already been made, and it was made by highlighting what was just outlined in red, which would have turned the points yellow, and you now see those points yellow in all of the open displays. If you're curious to know more about this particular glue screenshot and how it connects to concepts involving data dimensions and display and big data versus wide data, I highly recommend that you go watch those two other videos. But for now, let's just talk about the third meaning of glue in the name, and that's gluing together different tools. If you look at the top line of this graphic here, you see that the stuff in blue lists standard data loaders and standard kinds of plots that are built in that come with glue. But in the bottom, you see some purple boxes that talk about plugins that you can add that have already been written by other people or that you can write yourself to do things like load custom kinds of data or make custom buttons or features or include certain kinds of plots that are specific to the area that you may be studying. You can also run Glue from a Jupyter notebook, and soon Glue is going to run entirely on the web inside of a Jupyter Lab environment. More on that in a moment. Here you can see the list of plugins, or just a little snippet of the list of plugins that are already available through the Glue website, and there are instructions online about how to make your own plugins as well. Before I conclude, I want to emphasize this data dimensions and display aspect of Glue. We're so serious about that that there are even special functions like the one I'm about to show you that acknowledge that a dimension not only doesn't have to be spatial, but it doesn't even have to be orthogonal in some sort of abstract way. Let's take a look here at this actually pretty old video that was included by Chris Beaumont when he first started creating Glue a number of years ago because he was interested in the structure of galaxies, and in particular, in what it means to be able to resolve the gas in galaxies at different velocities. So what you see here is him playing around with an image of a galaxy where you can slide through velocity, which is actually the x-axis of the plot he just opened on the bottom. And then what he did was compress it over all the velocities so that he could see the arms of the galaxy very carefully. And now he's tracing out the arms with a little red cursor here and defining an arbitrary dimension that is the path drawn, that red line, that is the arms of the galaxy. And now he has this kind of ribbon plot that would be kind of a ribbon put into the screen, perpendicular to the screen along that red line that he drew. And so that's an XY plot of the emission along that arbitrary ribbon. that he created. So that's a pretty good example of what we mean about flexibility and employing these concepts of data dimensions and display. So I promised you one more glimpse of what's to come, and that has to do with Jupyter Lab. And so some of you know all about Jupyter Notebooks, which are a very linear approach to Python where you make a plot and then you have some code and then you put in some words and another plot. But it really doesn't do well in trying to see changes in many plots at once. Jupyter Lab is a different environment that will actually let you interact within one browser window with many sub windows. And so our current work on Glue is actually focused a lot on what we call Glupiter, that will allow you to have a desktop-like experience inside of a web browser. And if you'd like to help us with that or know more about it, look up the GlueCon series of conferences on the web, and we're happy to invite you. You can get more information, of course, at Glue's website, and there's plenty of documentation online telling you how to install Glue, how to build plugins, and giving you some demo data that you can play around with. So I hope I've enticed you and that you see where Glue fits in our grand scheme of letting people see more of the universe. Thanks a lot.